Now we have a working version of Skip's presentation. So Skip, you can come up and we will hear about building a 100-watt 6-centimeter amplifier.
Oh, I'm just going to clip it.
Got me a wire on there somewhere, sure. What do you do for a point or anything?
Yeah, right here, forward, backwards, and
Oh.
pointer.
Oh, okay. Yeah, good enough.
So there you go.
Okay, good enough. Man, that's bright. Anyways, panic time is over with. Now the nervous time is up here. A couple of years back, I was looking forward to trying to get something going for 6 centimeters, and I bought a couple of PAs from a commercial outfit in France. And they arrived finally, not a bad price, and I was stripped all the excess junk off it, and I had it on my bench with just loose wires for biasing and various voltages to fire these things up. And they were working. I had two of them. They were putting about 20 watts each, and I was going to somehow combine them together. When the first one was done testing, I took the second one, stuck it on my bench, and all these loose wires hang down on the edge of my bench, and on the edge of my bench, I have 110 volt plug-ins. The wires just happened to go right into the 110 volt plug-ins, and poof, vaporized everything. So I was down to one after that, and then I was kind of discouraged. So I said to myself right there, I said, well, I'd like to build something that I can repair, and because the parts, you can get parts for these things. So I just had to be wandering around the internet, and I came across, see if I can get this to work, Hans, SM6PGT. He had a presentation. I'm not sure where he had the presentation at, but it's probably one of the conferences over there, and he did some incredible testing. So I guess the overview is we're going to talk about him a little bit first, and I'm not going to cover much about his because you got to read his presentation. It's amazing what he did. I'm going to be more involved in the actual building of the facility because it's not that bad to build. Really, a learning curve for me is quite different. So I'll click one more time. What Hans did, these Cree GAN devices, which is new to me, he took a bunch of these, and they're available at DigiKey, and put them in all sorts of different test procedures and ran them at 50 volts instead of 24 where they're designed at, and ran the living daylights out of them until they practically destroyed themselves, and then took them. He's an RF engineer. And so then he cut them apart and take a look inside and just see what failed on them. And of course, there's heat. The single one, let's see, how's this laser? The single one that he played, that we use as a driver here mostly, he claimed that he had that thing keyed down for 24 hours and it never died. The other ones, the 35 and the 35 volt ones, or these ones here anyways at 40 volt, 50 watts, they lasted a fair length of time, but they got hotter and hotter and finally let go inside. And it was not so much the material itself, it was the wire leads going to the device that fried off. So he determined that under ordinary ham use, like we're not going to run these things like key down solid like maybe a commercial station would or something, depending on what they're doing, that under ham use and running them at 50 volts, we'll get good life out of them. So he did a lot, his experiments showed that. His board layouts, he did all the board layouts and stuff. So he'll send you the templates, and he's got a beautiful bias circuit that detects if the gate voltage gets lower than a certain voltage, it disconnects the drain voltage and all this stuff, and it works quite well. And I figured, well, this is for me. It's something I can build, and if I fried, I can repair it. I'm not having to worry about looking for some more surplus junk. His, I guess I look at here, but so his little 12 watt amp is very straightforward. It's what we use. It's the 12 volt driver that's going to drive the two 50 watt ones that come up with 100 watts eventually. Pretty straightforward stuff. I guess the real critical parts of these capacitors here, they got to be those glass type, if I recall what that was, or they're like a ceramic. There's the word I'm looking for. And but the rest of them, it's all surface mount stuff, fairly straightforward, nothing too complex. Oh. The board material? I'm sorry?
The board material.
Yes, the board material. Yeah, we're getting to that. Yep, you bet. Let's see what this. So this is the 50 watt, which essentially on the 100 watt job is just two of these put together with hybrid couplers. Sort of again straightforward enough. And let's see. So here's his original bias circuit, and this is for, let's see, this is the. Yeah, this is the original bias circuit, which I kind of found kind of odd because he come. Whoop. Let's go back here. Click. Push wrong button. Am I there? Yeah. He came in. He brings his 50 volts in here, and he has a little fuse here. These are all surface mount little fuse devices. And then he plucks off the 50 volts, knocks it down, and this is how he derives his negative voltage for his gates. Well, it comes in. Oh, wrong schematic. Sorry. Go back one here. Here we go. He came in here and he taps it off here to derive his negative voltage for his gates, but then he kept going along here for the drain and puts another fuse in line. So this fuse isn't really protecting any of this because it's got to be just as big as this one over here. So I thought, well, I'm going to make it a bit better and drive it this way. So I just, on the board, there's almost like he designed it. There was a pad there and everything to put a separate 50 volt connection and just cut one piece of the foil, feed 50 volts in here, and now this can be a smaller fuse, and it just protects the bias circuit, where now coming in 50 volts here, I have an external fuse. I figured no sense putting it on the board itself. There's a couple of schematics, a couple of things he drew wrong. I had to change this in the schematics and stuff, little things, but little. He admitted to me that he loves building stuff, but he's terrible at the paperwork. So there was some issues, but I won't get into that. He does fantastic work.
Real engineer?
As far as I know, he's a real RF engineer. Yeah, he works over there, and he comes over here to California sometimes too, and talks with the boys and stuff. And yeah. So the circuit board material, to make this crazy dual one, you needed two types of boards. Let's see. I started off with a 4350 and did not realize that was for the driver board. That's fine. But for the dual one, which has these hybrid couplers, you had to go to a more low-loss board. This is all new to me. This is a real learning curve to me. And I had made the darn board already out of this stuff. And I was showing it to him back and forth in email, and he says, take a look at your board there and look at the writing at the bottom. He had written on there, special board has to be the 5870. So I had to go back to what's their names, Rogers. There's the guys, and ask for free samples of that. Boy, I tell you, it's a good thing because this board material, like you say, I asked him, I might get some extra boards here. $10 a square inch for this stuff, I'm thinking, wow.
I actually sell it on eBay.
Who does? Rogers? Oh, you do?
I have that material on. Nobody ever buys it because hardly anybody ever makes their own board.
Well, okay, I'll keep you in mind. Is it cheaper than $10 a square inch? Oh, excellent. Okay, my next question for you, can you give it to me light sensitive? Yeah, there's see that. I've made boards, for years and years. I do a lot of pick work and stuff and make my own circuit boards but years ago I gave up trying to spray or paint on the emulsion to make them light sensitive because it was messy and it never worked out. But back then, MG Chemicals sold a spray. You spray the board, let it dry, it became light sensitive. Great for doing positive transparencies. I go looking for this. Nobody sells it anymore. So, I get a hold of Hans over there in Sweden, and I ask him, what are you using? And he tells me, he says, well, I'm using this stuff, get ahead of myself here. Yeah, it's hard to get, blah, blah, blah. So he tells me about this stuff. It's positive 20. And he showed me a picture, and I said, that's great. And he says he gets it at, I think it was Newark, if I recall. So I phoned up Newark in North America here, and they had an online site, and I found it. I said, I'd like to buy some of this off you. No problem. They come back to me. He said, suddenly, oh, wait a minute. We're not we're not, they can't sell it in North America for some silly reason. He couldn't tell me why, but they're not allowed to sell it in North America. He says, you can buy it in Europe, but here I can't sell it to you. I said, fine. So he gave me a contact, and I went to, where am I at here? I went to Farnell, I think it was in England, talked to him. I said, I'd like to buy it. Canada's $20, $30, something like that, not much. But he said, well, we need a FedEx account to ship it to you. Well, I'm screwed. I don't have a FedEx account. So I go to my local electronic shop and I talk to them, and he says, oh yeah, we'll get it in for you, no problem. We won't mark it up. They know me quite well. They had to buy 2 cans. I said, that's fine. So it took a few months, comes by, and the cans come in, and I go in, he shows me the invoice, and okay, they were 20 some dollars. The 2 cans were 40 some odd dollars, and then the shipping was 100 and some odd dollars. I says, well, okay. And he wasn't lying. He showed me the paperwork, but that wasn't the end of it. A week later, he says, Skip, you're sitting down. He says, yes, I got another bill from FedEx for dangerous goods. It was like $89. So it got expensive, but what are you going to do? So I'm hoping if somebody else has got ideas, like I've never done it, but some people tell me about these iron-on, you can, what is it? It's like an iron-on board. You iron it onto the copper, and then you expose it that way, and I guess you peel it off, I think it is. And I don't know how well it works. I've never used this stuff. Yeah, that's the thing, see, because, yeah, these boards get, the bias boards are pretty fine lined on it.
31 mil thick.
Yeah, that's just it. So that's the only snag we got for us over here in North America is getting these damn boards light sensitive, unless there's another way of doing it. But anyways, I figured, well, I'm committed now. So I got the boards. I finally got the other boards from Rogers, and the spray here, you put it on. If you let it dry by room temperature, it takes 24 hours. It's at 40 degrees C, 15 minutes. So Hans again gave me another good idea and built up a little dryer. And basically, it's just a Hammond box. Got 4 resistors in there. They're mounted right on aluminum, surrounded with styrofoam for insulation, and a little PIC controller. I can set the set points on there, what temperature I want it, and there's a little, where is it? Right here, a little temperature sensor, little Dallas sensors that have their own little data bit in it, eh? So you spray the board, lay it in there, get the cover on quick. I had it preheated and stick it in there, and 15 minutes later, it's good to go. So the transparencies, like say Hans did most of them, all of them I should say. There's only the little dryer board I redid some because he did an upgrade and he didn't tell me about it, and then he says, yeah, I wouldn't use it, it's got problems. So I was able to use a CAD program and I essentially just took this bias section off it and kind of imposed it on top of the driver board and worked beautifully. But you can see the transparencies anyways. He emailed me and he just, printed them onto a clear sheet, made sure the scaling was good. There is actually dimensions on it, what to measure for and all that, and we went with that part. Circuit board production, pretty well straightforward. I used an UV light after the emulsion. I can't remember this. I did some testing with ordinary FR4 board to just define my exposure time for developing, and I think it was like 3 minutes or something like that. I can't remember exactly. And then out of that into a developer, and then finally into the etchant tank, which I built up for other boards years back, and it's just a vertical thing. We've got a air bubbler, and there's a metal rod in there somewhere to keep it at 40 degrees C. And I use ammonium persulfate because it's so much cleaner than that other stuff, that brown yuck. Yeah, I just... No.
Used to be by positive resistant glass jar by actually the chemical.
Oh, okay.
So then we would spin it on.
Yeah, I remember back in tech school, that's how they used to do it for boards too, yeah. They'd pour it on.
We did microwave circuitry with that.
Yeah.
But the second thing was, do you use an organic chemical sulfate activated? Because that was originally like when you went, bought their ammonium persulfide etching system rather than the ferric core.
Yep.
They hate.
Yeah.
They had this little activator chemical.
No.
Put a few drops of that in, and that made it really cut fat.
Oh, really? No, never did.
No, it wasn't peroxide. Peroxide is used with the hydrochloric system, uric acid peroxide. But
Yeah.
God damn it, I can't think of who the people were that made the AC board etching stuff, but they told you.
Well, it was all MG Chemicals, the ones I ever dealt with, and they sold it in a little jug. It was kind of expensive.
Kepro
Oh.
etching system. They sold you etching tanks.
Yep.
We had all that crap. And there's this little bottle. It was some magic organic chemical. And it really made that thing.
It just
go fast.
made it feet go faster.
Oh, boy.
Well,
And then they used a spray technique rather than, did you have a bubbler in there?
yes, yeah. There's a black pipe that goes along there like that. It's used, that blue thing there is an old fish tank air pump, and it bubbles in there. And I used to try and do the boards on a flat tank that rocked. Well, the crystals would recrystal on top of the board and just ruin it. So I built this up, and talking about the ammonium persulfate. Yeah, you can buy this stuff, and they want enough money for it. But believe it or not, I'm from the oil field business. In the fracturing side, ammonium persulfate bags like this, warehouse full. So I got like 5 gallons of the stuff. When I left there, I took enough with me to last me forever. You know, so it's so much cleaner, and you can see the board being done too. You know, that sort of thing. That was one of the issues I had was I can't remember the numbers, but the one board material, I think it's probably what's in there.
Is it whitish?
It's whitish.
That's the 4350.
Yeah. Now FR4 board, when it dipped into the etchant, the copper's going to get away. It went kind of whitish. So, not thinking about this, I put this board in there, and of course it's white already. So I'm looking for it to change, and it's not changing. I'm looking at it. Finally, like, geez, 20 minutes, 30 minutes, and then I'm looking at it real close. I notice everything's disappearing. It's because I'm used to looking for a color change, and there was no color change. So threw it away, started again. The other board material is real dark brown, you know, and it's soft. Yeah, that's a thing I've discovered. Yeah, this stuff here, the 5870, which is the lowest, and it's like you can take this stuff and you can bend it around and cut it with a razor blade knife. I started using a little bandsaw I had, and realized I didn't need it, where the 4350 for the driver is much harder board. But it turned out good, and yeah, had to cut it out here because the driver, well, I think there's a picture next here. I'm getting ahead of myself here. Yeah, so this is going to be the final layout of the main amplifier and the 2 bias boards on each side, and there's the little wire jumpers going across for the voltages and so on and so on. So it cuts the fit. And I didn't have to make the bias boards out of well, here we go with the numbers. The expensive stuff I didn't think of, but I could use FR4. But when I did it, I didn't realize how expensive this stuff was, so I wouldn't have done it, but I had it, so oh well. So anyways, yeah, so since the boards are done, the next point was being double-sided is getting the ground plane coupled to the ground pads on the other side, and via holes.
Lay flat after you did your Z wire.
What's that?
How did you make it lay flat?
We're getting to it. We're getting to it. Yeah. So lots of drilling, and I just use ordinary, maybe a 20 gauge solder wire, maybe not even that big. Dropped it through, soldered it on one side, and then I clipped them off real clean with a sharp side cutters, and then carefully put the board with the soldered side onto made a little metal bump, we'll call it, and then set it on there, and then with it clamped off, I built like a little center punch with a small flat edge, and I just sit there and tapped and tapped and tapped and made them as flat as I could. Yeah, rivet them into it, and then soldered them. Well, there's the bulge again, but I started sanding first, but that was going to take too long. Got a Dremel tool out with a little grinder stone thing on the end, or it's like a sandpaper stone, and got it down flat. Now all the silvering, like I'd silvered these boards, all the silvering's gone off the copper, which is not critical. But that was for the vias anyways. But you got to be careful with this board, because if you're going to go tapping on it, and in the solder pad where you got it sitting on the metal stand slides off, man, that stuff is so soft the punch would go right through it. I was amazed how soft that material was. Yeah. So anyway, it took a bit of time to get it all sanded all nice and flat, but it worked. So next step was, of course, putting all the goodies on. And the first bias board went well. I built both bias boards first before I did the RF board and put power to them and tied up. And of course, one worked, the other one didn't. I had I can't remember, one of the 5-volt regulators or inverters didn't work to get the negative voltage. The neatest thing I bought was this USB microscope from China. I bought the cheapest one there was, and now they got them with nice little LCD screens, but it plugs in your USB, and the magnification's great, you know. And I found, just by studying, like, I knew the short was somewhere in here at the ground, but I couldn't tell which one, and I didn't want to start pulling chips off and stuff for cutting. And I just went and started examining. I noticed, I think it was was it a capacitor resistor? I'm not sure. Anyway, one of the parts, the little metal end leads, they kind of fold underneath. Well, I noticed it was not centered over the foil that was going underneath it. So I knew right away it had shifted down and probably bridged underneath. I took it off, sure enough, short was gone, away it went. It was like something like that, where it was soldered underneath, there's a foil going underneath and it bridged underneath. But it really does its job, but it does make you have a good look at your soldering and how ugly it looks. You know? But it worked good for that. So anyways, onward. What else? Oh, so the next step was the heat spreader. Now, Hans and I can't think of the other guy's name out there. Their heat spreader was a copper plate, and if I remember, it was 1/4 inch thick. No. Both these guys are in Sweden, or SM6, wherever it is. I think it's Sweden. I didn't know about PQ at the time. I probably could have got copper from him, but I already had a copper sheet. I had a 4x8 sheet of copper, 1/8 inch thick though, from years back, and I've been using it for this and that. 4x8 feet, yeah. Yeah, back in those old days when I got it from a friend. It was cheap, relatively cheap. It was back in the 80s, I guess. And his company we worked for, they owed him some money, and he was going to build stuff like this eventually. So he thought, back then we were thinking more of the circular rings for water-cooled tubes for 1296 and that. So he bought this. They owed him money. He bought this copper sheet, and he wound up giving it to me. So again, I didn't want to buy copper. I had this 1/8 inch stuff, so I used it. Let's see. Yeah. So wrong button here again. The driver, the little GAN FET freight is what they call a pill package. Again, that was something I never heard of before. It has no mounting tabs. Now the larger FETs do have mounting tabs, but like Hans said, what do we got here? I'm getting ahead of myself. Like most of those RF mounted parts, the tabs for the gate and the drain are sitting at a certain position. In order for the board to slide up and meet up with it, the tabs were going to have to be sunk into the copper, so there's a slot had to be milled into it. The driver didn't. It was a pill package sat right on top. So what they were using for their 1/4 inch heat spreader gave them enough room that the little SMA connectors, the 2 bottom holes, had some meat to go into. My 1/8 inch plate didn't have any room at all for that, so I knew I had to go do something different. So I bought what I planned to do, I bought a 1-inch block of aluminum, milled it off nice and square, and started putting and milled in some cooling fins. Hans said, you probably don't need it, because this thing does run actually a lot cooler than I thought it would. But he had his on he had a copper, thicker heat spreader than I did. And then he had a larger copper plate. It was practically the whole dish feed mount and all this stuff. I didn't want to go that way. Mine was going to be a lot smaller because I got to put the transverter up there and stuff. So I figured I'd do it this way. Plus, it gave me some material. We're still putting in the cooling fins. Didn't take too long, but back and forth. And okay, I'm getting ahead of myself again here. So got that lined up. Got the copper plate spreader made, and there's the milled in groove for the 2 GAN FETs to sink down lower into, so when the boards slide underneath, they'd match up nicely. Lots of holes to drill in. I think I used it wasn't smaller than 440. I don't remember the screws. Oh, I might have said 3/48 for all the little holes here. I did put some 632s here beveled in to hold the plate to the aluminum, put some heat sink compound in, set it down, and then then these holes are all for the boards, and they were pre-drilled into the aluminum. That's what was tapped for the 348s. Yeah, and I had actually milled this slot after the fact. Before, this is just on the picture. So anyways, with that thicker aluminum plate, I was able to then put some sides on it that bolted to the 1 inch, which gave me something to add the SMA connectors to and the feed through caps for the power and stuff. And, it's just some material legs to go on there with a cooling fan and so on and so on. And that was probably, best thing for the chassis. I didn't, quite often when I built something, I'll weld the corners, but I didn't bother because I figured if one of the FETs ever blew up, the boards have to be taken off and slid out from the sides. If I got these all welded up, you'll never get the sides off the silly thing. So it works great, and there's holes in it for a lid and all that stuff. And,
Question.
yep.
This is just the power amp, not the driver included.
This is just the power amp so far. I think I'll get pictures of the driver here eventually.
I tried to read on your schematics earlier, drawings of
Yep.
the amplifier, but I didn't notice the input power level or gain. How much gain do these GaN FETs have? How much drive does this thing need to make?
Okay. Actually, I think that got farther out, but what I'm driving it with is I'm just using a Coons transverter. And what does it put out? 200 milliwatts? 250?
That goes to the driver.
That goes to the driver, and the driver, if I had enough drive, would go to full 12 watts, but I'm only getting about 9.5, 10 watts out of it. And that's,
It's about 10 dB gain out of it.
yeah, I think I may have marked in there, but yeah, it drives this one just nicely, and I can just get it over the 100 watt level a bit, and then I run out of drive. And I find at that point it's saturated anyway, so. Okay, so that was the final. This is the little driver one. I actually built it first. It's like Hans said, build it for the experience and see what it's like. Again, the little copper spreader, and then you had to cut a hole in the board for the little pill package to solder on. That was the fun part. And this is the new bias board on his. I asked, well, actually, when I drew out the schematics and I drew out parts layouts so I could do it a little easier, and it just didn't add up. There's more parts on what I had for schematic and what his board had and all this. So I got back to him and I says, Hans, there's something going on here. Your board layout is missing this little chip. And he says, really? He says, that's right. And then I kind of back engineered, drew the schematic, sent it to him. He said, then it hit him. I said, oh yeah, I remember that. He says, that's one of my first prototypes. He says, I've upgraded. He says, what happened? He says, I had that all on the feed and I didn't have a cover on it. He says, he figures a piece of a snowflake landed right on the board, melted, shorted out. The cutoff circuit didn't work fast enough, blew the FET out of it. So that's when he changed to a different bias circuit. And he says, yeah, he says it'll work, but he also told me, he says, if you turn the bias pot too far, it'll go positive. Well, good grief. I don't want that on the gate. So I said, no, that's fine. I'll redo it. No big deal. So what I was kind of wondering is how do I solder these FETs to this copper, getting the copper hot enough. And I didn't want to just try and get a flow of solder and then take the FET and drop it in there and trying to hold it or whatever, and get in the positioning because it's kind of critical where it's got to line up everything on the board after a fact, So I put the board on and marked where it's got to go, and then I used this is the driver, yeah. I used it's a heating strip that they use in enclosures, 110 volts, and it just heats up, it keeps the moisture out, the frost out of the box, say. And I stuck that underneath the copper strip. There might be a picture out here somewhere. We'll see.
Electric hot plate.
Yeah, would have worked too. This thing,
Use them all the time to solder and stuff on doors.
this thing, I used a Variac so I could control the heat, and then I had a gob of copper here. Actually, was this the actual FET, or is that? Yeah, that's the actual FET. I put a copper layer and put some solder on, so I knew when it was starting to melt here, we're getting close. So I built this little jig that clamped on the copper, spring-loaded, and then especially the pillbox one, because this is sitting right on top. There's no slot for it to hold it in place. And I just got it positioned to let the spring do its job, and I heated it up and watched it. And when I saw this getting soft, I watched it, and all of a sudden, the little solder blopped out the side, and I think it's right there. And I figured, well, that's good enough. Pull it off, and then I slid the boards on. Everything lines up. The, yeah, I don't like putting parts in ovens. I mean, you know, I don't want to, I don't know. This is an experiment to me. It's new for me. And I just didn't want to cook the living hell out of everything. I wanted it, I wanted to see the solder melt and get it out of there, sort of thing. So positioning the bigger FETs here for the main amp. Now you remember the board was all one piece, so you had to slit it right down the middle because they got to slide in from this end and this end. And I got it in position, got it marked with. I think at this point I probably haven't milled in the slot yet, but it's just, you know. Oh, I know what I'm saying here is the tabs for the FET are way too big for the board, so you got to cut them off. So make sure when you look at the marks, you remember what the hell's the gate and what's the drain. Don't get them soldered in backwards. You know, I made sure of that because, hey, I've done it. You know, the other stupid things. So I got him in position and, oh yeah, and then capped on tape. I didn't want the solder flowing onto the copper, which will lift the board up. So it's, again, new stuff for me. I've heard of it, never used it before, and capped on tape with there. And it had to build a new holder for this, for the dual FETs. I didn't want to do one at a time. Stuck it in there and heated it up, and before you know it, it was really, I just watched them, and all of a sudden, bloop, right into the puddle. Took a bit of solder and just poked it in the mounting holes so they were full, and got it off quick and let her cool off. Yeah, there it is finished with the tape on and tape off. And you see I got drain and gate marked on there. So then, this is when I split the circuit board and they slide underneath. And when I first cut the board out, I'm used to using a little bandsaw. I put this on a bandsaw and I realized it's a soft. Use a razor blade knife to cut it. You know, so it worked good that way. So yeah, so it's on the heat spreader and bolt her in, and away we go. So the bias boards I did earlier, had them all proven out, tested, and working. So then it was a matter of getting the actually this board is a driver board. There's one little resistor on. Well, maybe I got a picture of it here. No, yeah.
Down there on that input hybrid, that branch line.
Here.
Yeah, you put the screw right there.
It's not quite touching, but it's pretty close. Hans designed it. I agree.
I guess if it works, you can't argue.
Yeah, I agree.
That's not considered good practice, though.
I would have had it more in the center, actually, but yeah, I know what you're saying.
Get it away from those microstrip lines, because
Yeah.
that field fringes out there around the...
Yeah. No, he's got one running, the other guy's got, he told me, I think, I'm probably the only fifth one to build one of these. And it seems to be working, so, I mean, it's proof in the pudding. Yeah, check for solder bridges, whatever have you, and get all the jumpers and stuff. And then put the chassis together and wire it up. There's, right on this, where are we at here? Oh yeah, there's a coupler here for sampling the output. And I kind of cut an SMA connector and got it standing vertically because I didn't have room with the walls to come out right off. On theirs, they have it mounted right on the, no, they didn't have, I don't remember how they did it. He came off sideways anyways, and again, I didn't know how it was going to work out.
You could have got one that had a little hardline pigtail on it, pigtailed it off.
Could have. Sure, could have, yep, yeah. So, put the walls back on, put the fan on, get the wiring put in, and on the testing. So now, back to the wires falling into the 110 volt AC socket. Not this time. I built up a proper chassis, and I put in, I got relays here for the drain voltage, one for the driver, two for each side of the FETs here. I had used ammeters on the side, and this was a gate relay, or gate switching relay, so they're sequenced. These won't come on without this, and so on and so on. Proper switching and stuff like that, because I didn't want to blow it up. So the next step I used, what have we got here? And it's interesting talk about the watt meters, or the power meters. So the measure thing, I got a big old Narda 20 dB attenuator here going into, I probably say here somewhere. I didn't say what day. No, I think I got that in the book. anyways, power sensor, I don't remember what they were. So one's reading the actual output, and the other one is with the HB 30 dB attenuator coming off the sampler here, going to the other one, measuring the drain currents and stuff like that, and moment of truth, put the power on and start turning it up using an old TS7. Yeah, and for 50 volts, I bought one of those server blade power supplies. Excellent for this stuff, you know, nice and small.
How the hell you keep your workbench so clean? Yeah, that's clean.
Okay, you say so. I don't know. You think it's that clean, really? Oh, I did it for the picture. I did it for the picture. The bench on the other side is where all the tools are. Yeah, there we go. Oh yeah, an 8481H power sensor was. Yeah, that's what I used. And I think, if I remember right, I took all this stuff and put it on an analyzer just to find out what the loss was, and it was actually a little less than 20 dB at that frequency. But that presentation for this was really quite interesting. Oh yeah, so what did I see? Did I see on there what I had going? No, I didn't. So when I first fired it up, I think I got up to, well, no, it wasn't 100 watts, but I think I actually got up to 65 watts or something like that. Oh, there we go. Oh, we just below 70 watts. Okay, so again, new to me was snowflaking. I've heard about it, never played with it. And Hans, he sent me pictures, and the other fellow, he's on the end of the presentation there, the other fellow I talked to a lot. They had a lot of snowflaking on theirs all over the place. And so I used theirs as a guide, and I just started placing here and there and all that. And some would help, some wouldn't, but it was mostly these babies right here that really took it up. And in no time flat, I had this thing up to 100 watts, give or take a little bit of inaccuracies in the watt meter. You know, so yeah, so it didn't take much at all. I went and put them in other places where they had put them, and it just went downhill. Oh, I'm sorry.
I just shout.
Yeah, you got to shout because I'm not looking at you guys here. So
During the Snowflake process, soldering, or you
yeah, that was the interesting part because I didn't have any real thin copper on the driver. I took a piece of copper flashing I had, and I hammered it flat or even at that, and used it. This here was just some thin brass that I had, and I just cut it out, and I laid it on there. I know that I read that you're supposed to glue it to a toothpick and move it around. Well, I couldn't get it to stick to the toothpick, you know.
That sticky copper tape that people use, like they use it in the stained glass window.
Okay.
They get some of that, and I used to take different sizes of the wooden Q-tips, cut them off,
Okay.
and just stick that stuff right to it, different sizes.
Oh, that would work. Oh, I was trying to use that toothpick, and I had some 5-minute epoxy, and oh, good God. I just see I'd be moving around and fall off and short something out. I said, so no, I would just take the piece, lay it on it, key it, try it. Well, that was just it. One of these I found it was laying on the solder. It was putting out good, and so if it worked there, then I soldered it down, and the thing went really flat, and the output dropped off. So I had to take the end, and I bent it up a little. Yeah, I guess, and the way it went. But mostly it was just these two here and these two are here, and then on the driver, I didn't show it. There's one on the input of the driver, but hands right on their couplers, right before the couplers, they had stubs on there and all sorts of stuff.
So when the big boys used to do this kind of stuff, because back in the day, microwave semiconductors were never uniform. So if you made a batch of something, you always were doing something like this in
Yep.
an amplifier.
Leave it out.
They would actually print little pieces of crack on the board beside where they thought the tuning would be. It could be bridged with solder.
Oh yeah, okay, yeah.
You had all these little patterns on
Sure.
the board near the transmission lines that looked weird, but they were for that.
They were there for that purpose. Yeah,
And it was
yeah.
real easy to short them with that toothpick or that.
Yeah.
And you say, oh, I got a bridge 3 of them, and then you just saw.
I'll be darned. Yeah, but I've heard of Snowflake. I never had a chance to do it, and this is my first time, and
Big time.
it worked good. Yeah, it worked good.
These were big devices.
Yeah. So, anyways, so a little bit of testing I did. I found that at 95.6 watts, I was looking at about 55% efficiency. What Hans had told me. As soon as I went over 100 watts, she dropped off. She was going off. Yeah. The driver, here we go. Driver amps, 8 watts to get 100 watts into the amp. The idling current, I set at 200 milliamps. This is one of the weird things was I'm measuring both sides, and one FET is drawing about 200 mils more than the other side. Just not. Well, I went back to snowflaking and I couldn't make a change. You know, I thought, only thing I think it was they're just not matched, not a matched pair, I guess they call it, eh? It doesn't seem to affect anything, it works. So anyways, at 95.6 watts, I was, I think both of them at 3.44 amps. And yeah, all this testing, I got the fan underneath. I never turned the fan on. I forgot all about it, you know. It hit me and I touched it, and it's just nice warm. Put the fan on and piece of cake. Run like a charm, and silly thing. This is the SM6FHZ. He's the other guy. This is the chart he came up with, the one he built. And showed you different things and what to expect and all that stuff. And it's pretty close. So, yeah, so next is, it hasn't changed much from what I've seen in the pictures. I've got to get the feed built and another tray. And I want to make, the transverter is going to go up there. I want to make the transverter adjustable, RF, you know, output-wise. So I'm really into like doing PIC stuff and data, remote controlling and stuff. So that'll be the next thing is that. And so on and so on. So, yeah, special thanks to Hans for sure. So he did all the work. And then Ingolf, he's the fellow that, Hans is a good guy to talk to. He's hard to get back to you though. And it's like a typical RF, I shouldn't say this, a lot of engineers are out here. Anyways, he would never get back to you sometimes. He's a busy guy. Where Hans, or Ingolf, he sent me a lot of pictures back on what he had and how he did this and told me this and that and so on and so on. And I have done one more thing. I have built a cover that goes over it now. And it's a nice metal cover goes over it, and then of course I expected this. It not so much the output, but that sampling port. It does. What does it do? Go up? I think it goes up a lot. So I got some RF absorption foam, stuck that on there. That helped, but it's still doing it.
I didn't want to say anything, Steve, but I looked at the width of your enclosure, frequency you're at,
Yeah.
waveguide, and that's why I asked you how much gain was in the box.
I see. Actually, the
Or it would have sung like a bugger.
yeah. The little driver unit there, I rebuilt the lid because it's got a lid that goes over it, and it used to go right across, and it's really close. To put the RF foam on it, it's touching the parts. You know, I didn't think, so I just made the lid bigger, taller, and it just sits up higher, and it didn't affect it whatsoever. But the bigger one, I don't know. Hans and Ingolf both says, "Oh, we don't put covers on ours." Well, geez. I don't want bugs in there, let alone water and everything else. You know, it's going to be double wrapped up, but.
I have to compliment you. That's really impressive. How long did it take you to do it? This is a big investment of time.
Well, the biggest, the most expensive part is that goofy spray, you know.
Apart from waiting for parts, there's a lot of labor there.
Oh, it wasn't
Get out of the way to make jigs and fixtures like most people.
I've been accused of being too much of a perfectionist, but I don't know. I enjoy it so much. This is what I get out of it. I'm more of a builder than an operator. I don't know. I think I built it all winter, you know, which is one winter sort of thing, and not that long. It just went together so damn well. I was quite tickled, you know, that way. And yeah, that's true. That's true. But it's
Yeah, but you gotta go out in the oil field with the Mustang part, right?
yeah.
You gotta work in January.
Yeah, well, not anymore. I'm done with that. But it's I mean, the two GAN FETs and the power amp, they're from DigiKey. Now this is Canadian dollars. They're just a touch over $200 each. The driver one was $70. That's the biggest pile of money right there for it. Other than this, we'll ignore the spray. You know, that ticked me off, but what are you going to do? Yeah, that's right.
What about the cost of the FETs? Because that's still not bad.
No.
But that's not cheap. You don't want to screw them up.
No, you don't blow them up. Well, I looked at the Kuhn stuff, you know, and good grief, it seems to me you get up there, it's like $100 a milliwatt. You know, the way I look at it, I'm like, oh, geez. So I figured there's got to be a way, and I just came across his one. I don't even remember where I found it, his slide on his testing and experimenting. And the more I read it, the more I got more intrigued. I looked up the FETs on DigiKey. Oh, they're there, and they're easy to get. So it just seemed like the thing to try. So
Well, it's interesting to see the GAN devices making their way into the hands.
yeah,
I watched GAN development for 20 years, and,
and boy, I tell you, they're like a tube. You know, other FETs I've played with, you got you positive bias on them to get them going, but these things, you take the bias away, and they're like a tube. They're going to full conduct. So he did a nice job on the bias circuit too. I guess I'm carrying on here
No,
as usual.
We've got some other questions,
Oh, sorry.
I think. So it's just getting Jeff to shut up.
Oh yeah.
No.
Mine's more of a comment, but I've done a lot of making of circuit boards, and the photographic technique is the best. But what I do now is I get this film, it's a thin film, and I put it on the board with a laminator, and you basically make a photographic circuit
Yes.
board like the ones you buy.
Yeah.
When I tried to buy that here in the U.S., it was extremely expensive because I had to buy large quantities, but I found on eBay out of Taiwan, they sell it in rolls of about 20 feet a lot cheaper. And I've been using that, and I have a good assess. I don't know what the fine resolution is, but I have done some fairly fine lines, mostly in lettering. Yeah, and like I say, I haven't had any issues. It does have a shelf life, though. After about a year, the timings I used for the ultraviolet light started changing the development time.
So it is a positive transparency.
Well, it's a negative, unfortunately.
Oh.
So you have to have a negative artwork on it. I haven't been able to find it in
and so you
positive.
do print to it.
Well, I don't print to it. I
do you-
build a photographic template off of clear material, but in a negative.
Oh, I see.
And then I expose it to ultraviolet. But you run this stuff on the board through a laminator, and now you've got a photosensitive circuit board.
Oh, I get you.
Printed
Well, that's
circuit board
different.
material.
That's a new way.
PC4 technique,
Yeah.
instead of putting something, spraying it on or whatever,
Yeah.
You laminate this, and then you got a nice film, and you put that material on the board underwater to keep the bubbles out of it and squeegee it on.
okay,
And then when it
okay.
dries, run it through the laminator.
Yep.
And it's the chemicals I got from Menards as far as the developer, whatever that potash stuff is.
Oh yeah.
And
yeah. Well, I never heard of that system.
acetone takes it right off.
I know
and
the
you're
guys
all
have told me
done.
about this stuff you iron on, and then.
Well, the iron-on stuff that
peel
you
it?
run through a laser printer, I have had terrible results with that.
Oh really?
No,
Oh, okay.
even on thick, because the transfer on the HP4, it thins out in wide black areas. So I've never had really good luck with that. But the photographic technique, especially using this film out
Yeah,
of
I've
Taiwan,
had different printers over the years, and then I know the one little HP laser I had to take two plastics and put them together. But I'm using this big Lexmark thing, and I just set up the settings, and it does a nice black job and seems to work. But yeah, anyways.
Hello? Question, the bottom side of the 5870 board, the bottom side, not the pattern side, but the bottom side,
Oh, the ground side.
the ground side.
Yeah.
Did you solder that to anything, or is that
No,
just...
it just bolts. It just bolts on top of the copper plate. Like
Okay.
right there. It just
Yeah,
bolts
some
solid
people-
onto it.
Some people have had problems with high-power amplifiers with inadequate connection between the bottom of the board and the bottom of the device.
I think that's why Hans put so many screws in it. You know,
Yeah, that
there's-
helps,
There's
but-
screws everywhere, especially
but-
around the FETs themselves. You've got
Right,
screws here and there.
exactly. That's
you know,
very
every hole
helpful.
there was a lot of screws.
It's very helpful, but it's amazing how little
Doesn't
of
take
a
much.
missing connection can make big,
Yeah.
big differences in output power.
And especially with that soldering those tabs on the bottom and get them sanded flat. You know,
at least on the output.
soldered to the copper, copper plate.
Yeah, see, what he's saying is
Ooh.
very true.
Yeah.
In commercial practice, that's the way they do it. But
Yeah.
because you've got to be able to pull them apart,
Yeah.
but don't solder the input side. That's not the high power side. You solder the output side and then just pull the FETs from one side.
Yeah, but if I have to take these FETs off and they're soldered on that copper plate, that means I'm going to have to heat the living daylights at everything, and now everything's going to get hot, and
Yeah,
you know.
that's the way you do it.
Ooh. Well, what about just taking strips and soldering them?
You know what?
No. Okay.
Talk to me afterwards.
Okay.
Here, I think I heard Paul Wade say.
Oh yeah, we're probably overdoing it here as usual. Good thing I'm at the end because I
Yeah.
tend to go on.
Yeah,